guys, I'm going to review all the different ways to solve a quadratic equation. So the first way is to solve by factoring. So I'm going to take this 8 and I'm looking for two factors of 8 that would give me a sum of -6. I'm going to use -2 and -4. So I would say x minus 2 in parentheses and x minus 4 in parentheses. Then I take each factor and set each factor equal to 0. And now I'm just going to solve this resulting one-step equation. So the opposite of subtracting is adding. So I get x equals 2. The opposite of subtracting is adding. So I get x equals 4. Therefore, my roots, solutions, zeros, whatever you feel like calling them, are 2 and 4. Okay, solve by factoring. This factoring is a little bit different because there is no constant term. When there is no constant term, it's probably a GCF. So I'm going to pull out the GCF of x by dividing x squared by x and dividing -6x by x. Then I set each factor equal to 0, and I get x equals 0 and x equals 6. This gives me roots or solutions or zeros of 0 and 6. Keep in mind, any time that the constant term is missing, one of the factors is always 0. Okay, so now factoring again. I have a 3 here, and I was hoping that I could divide everything by 3, but I can't. If you can't divide by 3, then you're going to have to do splitting. So I do 3 times -8, which is -24, and I'm looking for sum of 23. So I'm going to use a -1 and a positive 24. So that gives me 3x squared minus 1x plus 24x minus 8 equals 0. I'm going to factor just the front, the first two terms, and that's going to give me x and 3x minus 1. Now, I'm keeping in mind that that 3x minus 1 is going to be repeated because these factors have to be the same. And now I'm looking here, and I know that I'm going to pull out an 8. That 8 is positive, so I'm going to put a plus there. So that gives me x plus 8 and 3x minus 1 equals 0. Those are the two factors. So I'm going to set my two factors equal to 0. So x plus 8 equals 0. So x equals -8. 3x subtract 1 equals 0. Opposite of subtracting is adding. The opposite of multiplying is dividing. So I get x equals 1/3. So these are not integers. Well, the -8 is, but the 1/3 is not. However, they are rational, so therefore I should come up with the final answer. And that's solving by factoring. Now I'm going to do completing the square. Completing the square uses my favorite of all trinomials, perfect square trinomials. So the first thing that I'm going to do is I'm going to leave a space for what I need to make the left side a perfect square trinomial. So I'm going to take this -6 divided by 2, that gives me -3. And I'm going to take that -3 and I'm going to square it, which gives me 9. So I'm going to add 9 to both sides. The reason I added 9 was because I was creating this perfect square trinomial. Perfect square trinomials factor into squares. So I have x minus 3 squared equals +1. Oh, I like 1. 1's a perfect square, so I'm going to get a rational answer. I take the square root of both sides, and that gives me x subtract 3 equals ±1. Okay. Now I just have to finish this by adding 3 to both sides. And this is going to give me integer answers. 3 plus 1 is 4. 3 minus 1 is 2. Completing the square. I'm going to solve by completing the square again. X squared plus 10x, leave a space, and move the 10 to the other side. I'm trying to create a perfect square trinomial. So I take the 10, divide it by 2, that gives me a 5. I take the 5, I square it, that gives me 25. So what I'm going to add over here is a positive 25. I'm doing that to create a perfect square trinomial. Perfect square trinomials factor into squares, so it's x plus 5 squared, and that's going to equal 15. 15 is not going to give me a rational answer because 15 is not a perfect square. I'm still going to continue and take the square root. That gives me x plus 5 equals plus or minus square root of 15. The opposite of adding is subtracting, and this does look a little strange, but it works out nicely to x equals negative 5 plus or minus square root of 15. I'm going to leave it like that because it's an irrational answer. Okay, last method, quadratic formula. So I'm going to start by identifying what is the a, what is the b, and what is the c. So the a is the coefficient of the quadratic term, the b is the coefficient of the linear term, and the c is the constant. And now I'm going to substitute them into the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Now I'm going to substitute. X is equal to the negative of negative 6 plus or minus the square root of negative 6 squared, subtraction 4 times a 2 times a 9, all over 2 times 2. Okay. X is equal to, the negative of a negative is a positive, plus or minus square root. I'm looking for the discriminant. 2 times 2 is 4. So now I can put that in my calculator, and I'm going to do that right here. Just make sure you use the parentheses. So negative 6 squared, subtraction 4, parentheses 2, parentheses 9. And I'm going to get, oh no, negative 36. Okay, we haven't talked about that. That's actually going to be an imaginary number, so I am definitely not going to touch that. So that actually means that not only is this not factorable, but it doesn't have any real number answers. So I'm just going to leave that the way it is, not going to touch it. You should get positive numbers or 0 here. When you do get a negative discriminant, that tells you a lot. That tells you that you have no real roots. So don't touch that. All right, happy studying.